Alright, we're going to continue on a little bit of our pseudocode flowchart, and we're going to do a little bit of Python today. I'm going to use some notes that Jeff made. We covered a little bit of it the other day, but let's start talking a little bit more down here. Alright, I talked about flowcharts, so we pretty much covered this one. Flowcharts, I don't think we got to this, did we? We didn't get to this page, did we? I am recording, aren't I? Yes, okay. With flowcharting, first of all, you start with a terminal character, which is like this oval. Then we have a flow line. Whenever you're writing a program like in here with a flowchart, you should always have flow lines to tell you how to go. If you leave off the flow line, it's kind of like you don't know how to get where you're going, okay? The input-output's normally in a parallelogram. Then we have processing. Processing is where you could do some math, you could do whatever, okay? Then we have decisions, then we have module calls and stuff like that, but we're probably not going to get into that at least for a little while. Alright, let's talk about looping now. I'm going to make this a little bigger so those of you in the cheap seats, again, can see this. Okay. So here's some code we got. We say start. That's our terminal. We're going to begin here. Input number. So what is input number going to do? Anybody? It's going to ask a question. It's going to get input for a number. We don't know particularly exactly how it's going to do it because we don't know a language at this point. We're just saying get input for a number into my number. Okay. In a pseudocode, we don't want to tell them using using print parentheses whatever. Don't do that because, again, this should work with all languages. So get input for a number. Then we say set my answer equals my number times 2. So we're going to create a variable called my answer, and we're going to set its value times whatever's in my number times 2. Now we could, some people say, well, you really didn't declare my answer yet. Well, you kind of do by doing that. Okay? Depending on the language you're working with, like in Visual Basic, you don't have to declare a variable. You can, but if you don't, it automatically declares it as something called a varchar, which is kind of a generic, it's the largest variable needed, and it just does it. So you think it's a good idea or a bad idea? The Visual Basic automatically does it for you. What do you think? I think it's good for lazy programmers. But it's bad because it puts it in this data structure in this variable that's huge. Maybe we're storing the number 2. Do we really need to take up tons of memory to store such a small number? No. Okay? So then we could output my answer. Again, we're not telling it how to do that. We're just saying, I want you to output my answer. We're not saying where to put it. We're not. I mean, you could say output to screen, but still, we're not telling them how to do it at this point. Then we're going to get input from my number again. Then we're going to set my answer equals my answer times 2, then output the results. Then we're going to input again. So you notice how it's going over and over and over and over and over. Okay? Would you like to write code like this? I have students who do that. I do a project in another class where they literally, this guy turned in a program. You could very easily write it in 5 lines of code. His was way over 700. It's like, why? Why would you do that? I mean, yeah, it might be really easy, but come on, seriously? Why would you do that? It's like if I'm going to drive from Choctaw to here, yeah, it would be simple to just cruise around up through Edmond and down through Norman 12 times, but why would I do that? It's shorter just to drive straight here. Well, when writing code, I always try to look for an easier way out, okay? So, I actually, yesterday, I wrote a Python script, which I'm going to cover today in the 2 o'clock Cyber Club meeting. I wrote a Python script to open a file and calculate the index of coincidences, which is needed for the cryptography class. I spent nearly 2 hours on that. It should have taken me 10 minutes. Well, I messed up. Where I declared my list, I did it wrong. It worked, but I did it wrong, and it took me, I even had Roy come down. We're looking at it, you can't see it. It's one of those things, when you make a stupid mistake, and you're like, you can't see it, and I tried. So I told my wife I'm going home at 3 o'clock. I went home a little after 5. But I finally figured out, I'm like, boy, was I stupid. And once I fixed that problem, I had another little stupid problem. Once I figured, I'm like, oh, I just mistyped it, okay? But writing code like that would be crazy. Yes, it will work. But say we're writing this code, and I want to rename my number. I want to call it my num. What would I have to do? Change it in all 942 times. No, I could use the search and replace feature, but still would have to be changed in all those places. There's got to be a better way to do this, okay? So how could we fix this? Well, we could do something called looping. Let's look at this pseudocode of a loop. We're going to start something. That's our terminal again. Now the flow line, there's actually 2 of them there, but we're going to flow down. Since the other one's a one-way, we can't go that way, but we're going to go down and we're going to get input from my number just like we did above. Set my number equals my number times 2. You'll notice that the input is in a parallelogram. That is a parallelogram, isn't it? Yes, okay. Okay, because it's been a while since I had geometry. Is that geometry? Yeah, been years. Okay, so that's our input-output box. We're getting input. Then this is our process box. This is where we're declaring our variable and setting its value. Then we're outputting the number. Then we say, you know what, go back and do it again. So yes, this is actually much better because I only had to write the code one time. You with me? But the problem is, like it says here, how do we stop? You know, when do you stop? Do you ever stop? Okay? In this case, we don't. We will be literally going on forever. Now, I could always do Control-C to stop it. I don't know if you didn't know that. You can do Control-C to stop your programs. But years ago, you couldn't do that. I used to teach a networks class, and I talked about process affinity, and processes use up a lot of power. And what I would do was I would go into the computer. Remember when Windows used to ship with pinball? Anyone remember pinball? Okay, it's not there anymore, is it? That was a pretty awesome game. Well, what I used to do as an example for the students was we'd bring up pinball. Then I go into the task manager, into the processes area, and say set pinball to real time, which means that's the highest. It's the highest priority level. So I don't care what the operating system is doing. Pinball's number 1. Okay? Is that a good plan? No, because then your mouse stops working, your keyboard stops working, everything, because it's like pinball. But it does. I mean, it literally takes over your entire computer, and the computer locks up, and you can't do nothing. So it's a good example of why not to just mess with priorities. Okay? So, like here, again, this is a great idea, but we're missing something here. Again, you can do that, and you can get Control-C, but okay. So let's continue on a little bit. Okay. So how would a flowchart, this is how I would flowchart the previous example. Okay. So now we're going to say start. Okay. Then we have a while true. Now we have, this thing is called a decision structure, this diagram. Do you all know how to make flowcharts? There's actually one called Lucidia chart, but I'm just going to show you a couple other ways. I'm going to do it in PowerPoint. I have PowerPoint here. Y'all know that your Google Drive now supports the creation of Office documents, actual DOCs and XLSs and PPTs. I'm not talking Google Drive documents. I'm talking actual Office documents. Do y'all know that? So you can use Google Drive now to make Office documents. So I'm going to bring up a blank slide. I don't want to see this junk. I don't want to see any of this, actually. Go away. If you've never used PowerPoint, it's pretty simple. I'm going to create a new slide. Why? Oh, because it opened up the stupid one for that stupid program I'm running. Camtasia. There it is. A blank presentation. Now I have a blank presentation. I'm going to set the layout to blank. Now, inside PowerPoint, you can actually use Insert, and you can go over here to Shapes. I mean, follow along if you want, because you're going to have to do something like this. But I'm over here to shapes, and I can insert stuff. So what do you think I might use for my terminal character? Anybody? An oval. Do we see an oval? How about this thing? I know it's hard to see. Then I'm going to click here. Now I have an oval. Is that an oval? It's a circle. That's now an oval. Okay? Now if you do this, let's talk about how this thing works. Bless you. We're going to click on this and we're going to change our outline. We'll change it to black. And we're going to change our fill to white. I just took out the inside. Okay? Now I can click in it and I can actually go text box in it right here. And I can say start. Well, heck. You can't see it. Does anyone know why? So now I'm going to go over to my text and say make it black. Then I can go back to home and I can say, I want that text to be 28 or whatever I want it to be. Easy enough, okay? Some people, when they do this, they have issues. They start with a very small box and it ends up like that. Okay? So if it's too small, just make it bigger. Okay? And then you can move it around. You can grab the sucker and move it. You can actually even rotate it. Pretty simple. For anyone, is this your anyone here first time using PowerPoint? I mean, some of you it might be. I use it all the time. Okay. So, we got our start. Now I'm going to make a, let's see, what was that flowchart we were looking at? We need a decision structure now. So I'm going to make a decision structure. So I'm going to go Insert, Shapes. I need a diamond. I know there's one here somewhere. There's even a section called flowchart. Now I could have actually used this one over here for my start, my terminal character, but that's okay. They're both close. I'm going to Insert, Shape, and under Flowcharts, I'm going to pick Diamond. I'm going to dump it right there. And you can move it. The way you move it, just drag the edge. And I want to put a text box in there. And I'm going to say, while true. Okay? All right. Now, there's another way to change this shape. I can actually click right up here under the shape styles, change it automatically as well. I can change it to all kinds of stuff. I can change it to orange. Or if you're an OU fan, I can change it to OU. Okay, good. I can change it to that. So there's a lot of different ways to play with this stuff. You can just click on the styles and change it to whatever you like. When submitting homework, I would like it just basic, okay? I don't need any fancy. It's like my secretary downstairs. On all her emails, she has a background and this stupid side thing, and it's like, but it's so pretty. You know what? It might be pretty, but it's not functional. I'm a guy. I want functional, okay? So while true, okay, we need something between there. And looking at this picture, what do we need between there? What's that called? What? An arrow or a flow line. Very good. Okay, so now I need to add a flow line. Again, I'm going to go over to my shapes. Now, there's no arrows under flowchart. Well, heck. But there's an arrow up here. So I'm going to click on that line. Now, the cool thing is, when you use lines, it'll actually, see when I move it over these, see how it makes spots? That means it wants to start there, and I want it to go to there. And now watch what happens if I move this, that line actually stays connected to the start. Y'all see that? As long as you start it at one of those lines. Now I'm going to click on mine. I want it to be a different color, so I can click here and I can change it to black or whatever I want. But you can also click here and go to weight and make it thick. Okay. And then it really should be linked to both of them. Whenever I move either one, it should stick with it. So that's kind of a really handy feature. Especially if you're making a flow chart and you don't really know what you want, and you start adding stuff to it and it won't fit on the page. If you didn't link them to the object correctly or attach it to the object, then you got to move the object, then move the line, and move the next line, and it's really... Is everybody kind of following along here? Any problems? Yes? Maybe? No? Okay. Alright, so we're going to start and we're going to do while true. Just that right there, what do you think would happen if this was a program and I ran this? Any ideas? Would it ever quit? No, it'll literally just go forever. While true. Okay? So let's look at this next guy. So, normally when you have flow lines leaving a decision structure, you need to label them. Yes and no. Okay? This one's only labeled once. Okay? But now we're going to get input. So I need a parallelogram to get input for my number. So I'm going to do insert menu, shapes, flowcharts. I want this guy right here. I'm going to put him over here. I want to change his style to plain old black and white because that's cool. Got my guy. Okay, input my number. Okay. I kind of like the way this one looks better up here because it's bigger start, but either way is fine. Now I need another flowchart. I'm going to go insert, shapes. Let's add an arrow. And you'll notice it automatically, as I move over the shapes, you'll notice those little circles appear. So I want to connect it here, and I want to connect it to here. So now when I move it, it should be attached, and it is. So for this line, I want to make it black, and I want to make the outline a 6, so it's nice and thick. Now I want to stick a text box. I want to say yes. Now that text box is not attached. So if I move this, you'll notice the yes is not attached. Okay? Kind of with me? Kind of following along? Again, if you do this correctly, there's actually software that will take this and convert it into a program for you. Okay? Alright. So now, okay, we're going to set my answer equals my number times 2. Okay. So what type of symbol do I need for that? I'm going to set something. Anybody? I'm going to wait until someone says something. It's what? I heard 2 people say something. I didn't catch either one. A rectangle, but what's it also called? A square, but what's the flowchart name for it? It's actually called a process symbol. So I'll call a process symbol. Okay? So I'm going to go in here, I'm going to select this. Do it here. Alright, I want him to be that color. I'm going to say text box inside here. Set my answer equals my number times, that's a plus, times 2. Alright, and I think I can make them a little bit smaller, so there you go. I like that one better. That was the next thing I needed to do. I need to output it. So I need an input-output box again. So I'm going to pick, you know what? Hold on. Rather than put a new input-output box, you know you can actually take an existing object, copy it, Control-C, then paste it with Control-V. And it actually keeps the exact formatting of the original object. So now I can say output my answer. That way I didn't have to change the style. It was exactly the same shape, exactly the same size, and everything. Okay? Alright. Need some flow lines. So I can actually take this line right here, copy it, because it's already the right size. I'm going to go over here and I'm going to attach it to this guy, then drag this guy and attach it to this guy. Then I'm going to copy him, attach the end of him down here, and attach the other end of him down. We'll do it to there. Alright. Actually, I want to show you something here. See, if you don't attach it to one of those points, if I just do it there, see when I move this, it's not attached. See? If you attach it correctly to one of the dots that appear, it does it. Now, if I move it, it will be attached. That's probably one of the biggest things people have an issue with. Then if they move their stuff around, then they got to totally fix everything. Okay. Now in here they have a flow line. Now we need a flow line to go over and up. Now in here you can actually do these kind of flow lines. It actually has a bend in it. So I'm going to start here. And I want to go to here. Again, this highlighted. Now you could actually even move it. Well, I want it to be attached. Stay attached. It's not attached. Darn it. Hold on. See how you can actually change the shape of this line? Yeah. Okay. Now we change it to black. And thick. Alright. You know what? The whole darn thing is too low on my page. And here you can actually select it all, and then you can drag the whole thing up at one time. Just hitting the up arrow. I could just drag it as well. So was that hard to create? Pretty darn simple. You can do the same thing in Word. We're not going to do the whole thing. I'm just going to show you. Side Word, I can go Insert, Shape. I can do the same exact thing. I can put in this symbol that I can do. I want to add, let's pick this symbol. So I can do the same thing as Word. Okay? You can actually do the same thing in Excel even. You can do it in all of them. Okay? And you can always click on these and rotate them. Okay? So you can do it in either one. You can even do it in Google Docs to an extent. You can't do everything, but in Google Docs, if you create a new Word document, then you can. All right, so is this flowchart good? I mean, is it correct? Would we write a program based upon this? Or is there any issues with it? Anybody? Come on, there's something wrong with it. Exactly. It says while true. We're going to go forever. Literally while true. Okay? When are we setting it to not true? Okay? I haven't looked. Hopefully he fixes that here somewhere. But it's an infinite loop again. So how could we fix it? We could say while my number is not equal to 0. Since our flowchart over here is getting input, okay, we can continue as long as it's not 0. But let's look at his here for a second. I'm going to shrink it down just a little so it fits. Okay? So this says start. Set my number to 1. So it comes down here to the decision structure. While my number is not equal to. So the explanation equals is not equals. Okay? Think of an explanation symbol as a not. Okay? So while my number is not equal to 0. So if it's not equal to 0, that would be true. So then we go get input. Then we check it. If my number is not equal to 0, right here, so if it's not equal to 0, so if that's true, we come over here and do our math, we get output, then we go over here, okay? This is just a connector symbol, okay? Then we did output. So we'll just say we entered a 5, okay? So we started at a 1, we checked it, 1 is not equal to 0. We got a 5. Come on down here again. It's not equal to 0, so we go yes. So we do our math, we output it. But it's still equal to a 5. So we come down here. While not equal to 0. So 5 is not equal to 0. Continue on. Okay? Everybody with me? Well, let's pretend. So say I did that 5. So I set it to 1. I input a 5. It's not equal to a 0. I do my math, and I output the results. All right. Then it comes back up here. 5 is not equal to 0, so I get input again. Now I enter a 0. So it says if my number is not equal to a 0, the answer is not. It is. So if it's not, so it is equal to a 0, so that would be no. I hate double negatives. If my number is not equal to 0, so if it is equal to 0, the answer is no. So then we can cruise down here, and then we check it again. It's equal to a 5, and then we quit. So you think that solves the problem? Actually, it does. It solves it perfectly. It's kind of weird. See, there's a couple different types of loops, which we haven't got into both of them yet. There's, let me write them both in here. Okay, we have a do and a while, also known as a do while. Those are really, there's more than that. But we have a while loop, which we just looked at. That's what's on our screen. Also known as a do while loop. Then we have a do loop. Let's talk about the difference of these. So this while loop here, what happened if my number started off at 0? Okay? Would this stuff on the right ever have been processed? No. If my number was 0, it would have quit immediately. So a while loop, what's the minimum number of times a while loop must be processed? Remember, if we set it to 0, it'll never be processed. So the minimum number of times is 0. See that? So if we start off at 0, it'll never be processed. Now a do while loop, say there's a do, actually, you know, I wrote these wrong, sorry. My bad, that totally belongs up here. My bad, totally. Can't believe I did that, my fault. Okay. So a while loop, the one we just talked about, I can't believe I did that, sorry. The while loop doesn't necessarily have to be processed. Think about it. How many of you are employees of Rose State? I'm assuming nobody. Wow, okay, one of you are. Okay, how many of you are employees of Park University? There you go. None of you. Okay, so while you're an employee of Park University, give you a paycheck. Well, you're not an employee of Park University, so you don't get a paycheck. Make sense? Which is good. Well, a do while says do something, all this, while this is true. So if I said do, and the context was write a paycheck, as long as you have an employee at Park University, what would happen? It would write you a check, then check to see if you're an employee at Park University, and it would say no, and then it quit. But a do while loop processes at least one time. Okay? Also think of it as a grocery store. Okay? Are you going to go to the cashier or not? You know? Do while means do go through the cashier while you have something to buy. You're still going to go through it. But a while loop would say while you have stuff to pay for, go through the cashier. So do is what's called a post-test loop. So a do loop is really a post-test. We're going to do something and then check. Okay? While is what's called a pre-test. We're going to check first. Okay? So let's talk about umbrellas for a minute. Anyone in the military in here? Ever? Okay. It's funny because for years in the Air Force, men were not allowed to use umbrellas. That was a rule. Men cannot use umbrellas. That was the rule. And about 1988, the Air Force changed that so the men could use umbrellas. I still remember that day. We're sitting there at our commander's call where Colonel goes up and talks to everybody. He's like, all right, new ruling, men cannot use an umbrella if you're a pussy. Sorry, excuse my language, but that's what he said. His point was you can do it. But, okay, so let's talk about using umbrellas. So, what type of loop would I use if I need to determine if I need an umbrella or not? So remember, we got a post-test and a pre-test. I need to know, do I need to grab my umbrella today? So would I do a pre-test or post-test? I'll do a pre-test. Is it raining? No, I don't need the umbrella. Yes, I'll get my umbrella. Can you imagine a do loop? All right, fine, I got my umbrella. I go outside. Oh, it's not raining. Why did I got the darn umbrella? So you see the difference between pre-test and post-test? Yeah. Okay. Think about it going out to the movies. All right, so I'm going to go to the movies. Actually, I'm not going this weekend, darn it. But pretend I'm going to the movies this weekend. And I need to determine if I have any money. So would that be a pre-test or post-test? It'll be pre as well. While I have money, so I check. Do I have any money? No money, I'm not going to the movies. Can you imagine if I did the pre-test? All right, great, I'm at the movies. I drove all the way over here. Darn it, I have no money. And no, I can't use credit cards. Okay, so you see the difference there. How about, let's think of an example for the other one. Say we all work for Rose State. And we all are employees. No, that won't work either, darn it. I'm trying to think of an example. Well, just know that we check afterwards. We do the task, and then we see if we want to continue or stuff like that, okay? Actually, I guess we could do that. We could write you a check, and then as long as you're still working here, so I pay, so I'm getting paid, I guess, tomorrow. So they're going to write Ken Dewey a check. So they're going to do the process of writing me a check. And then they're going to, okay, post-test, is he going to continue working next month? Yes, and then start, keeping track of it for next month. But yeah, so two different kinds. So this one here, is this better to have a pre-test or post-test? Pre-test. Because what if I set it to 0? What if I don't want to do this? So while is not equal to 0, do this addition. Okay? Or what if we change this so this was divide? Well, no, that wouldn't work either. You know that whole you can't divide by 0 thing? Yes. I still don't believe that. Why? If I can divide by 2, why can't I divide by 0? I've watched countless videos. I've had mathematicians explain it. I still don't understand. No, you're just telling me it's an error. How do I know it's an error? How do you know you're just not telling the computer, hey, if he puts in divide by 0, I'll put error. Why can't you do it? No one has been able to explain it until I'm happy yet. It's one of those things I just don't. I've had Roy and me sat there for hours trying to contemplate dividing by 0. And I still think it's a scam. They just don't want to divide by 0. That's what it is. So, all right, let's continue on. Okay. Or we can use a query, okay, to terminate the loop. So we get a response is equal to yes, while response. Now, check this out here. This is different. You see something different between these two questions? See something different? One has a single equal, one has 2. Okay, a single equal is known as what's called an assignment operator. R is equal to yes. Okay? We are assigning the value of yes to R. The second one says R, is it equal to? Yes. It's asking the question. That's what's called a relational operator. Is it equal to? So this one is R is equal to yes. The second one says is R equal to yes. Okay. So a little bit different. Okay. So while R is equal to yes, get input for number, do our math, output the results, then get input. Would you like to do this again? Which is probably a better choice rather than setting it to 0. Then we come up. Yes or no? And we continue on. Make sense? So we actually got rid of a loop. So if you look at the difference. See this one, we got this whole if number is not equal to 0 thing. See, if we did this one, there's actually something missing. You want to know what it might be? I haven't talked about it yet. We should really be telling the user, enter your number or 0 to quit. Make sense? Because how do they know it's going to quit with 0? They might be like, why does this thing not exit? Well, we didn't tell them. Hey, enter 0 to quit. Where the second one, would you like to continue? Yes or no? It's a little bit better in my opinion. Okay? That's all right. Let's continue on. All right. Here's some Python for it. Okay? X equals 1. Now, first of all, we got some comments at the top. Comments important. We talked about them. I want to show you something. I need this file anyways. This will be a great example. Let me pause this recording just for a second. Alright, so I wrote this program. We are recording again, are we? Okay. I wrote this program last night, like I said. It's going to take this file full of text right here. If we actually turn on word wrap, it's actually, you can see it a little better. This is from 1972, some random text I found on the internet. So it's going to take it, it's going to calculate the index of coincidence. Okay? Now, let's let this thing load. See any comments in here? No. I want someone to tell me what this does right there. Anybody? What's in the middle? What's this right here? Plain English to me, I totally understand what it does. I wrote it myself. I want to understand what it does? So you think I probably should have put a comment in there of what this is? Yes. Reason I didn't is I wanted a good example of why you need comments. To me, it's like, yeah, we're just checking the ordinal value of a list minus 65. So I'm taking the character, converting it to an ASCII value, subtracting 65, so capital A becomes 0. Done. It's like easy. But still, none of you had a clue what I said. So this is a prime example of why we need comments. Okay? Everybody agree? Okay. So back to where we were at. So adding comments to our code, and it might seem trivial to you, but how many knew what a sentinel, okay, how many of you know what a sentinel value is now? Probably a couple of you. A sentinel value is a starting value. Now, I'm not saying we need to make our comments stupid, like create a variable to hold an integer and call it x, period. Set the variable x to the integer value 1, period. This variable will be used to do blah, blah, blah. I mean, that's like a little overkill. But if we did that, would that be a bad thing? Not necessarily, because, you know, my stepdaughter Bethany came to a Python class over the summer and she loved it. But she could probably understand that and figure out exactly what it does because of those extensive comments. So comments are a good thing. So let's let's talk about what this one does here. So we're looping with a set and a value. We set it to a value. Ball is not equal to 0. You know what? This sounds like something we really need to do. Let's do this. So let's open up Mr. Python here. Now, if you don't want to search, click on programs and all, you can always just type idle. It comes right up. You know, we have so many programs installed on our computers nowadays. I don't ever try to search for them. Just type the name of it. Like say I wanted to run Word. Comes right up. So I'm type idle, and there's idle. Click on it. Just saves me from start, programs, expand all programs, go down to Python, expand Python. All right. So let's create a script to do this in. That way you can submit something. Because if I just run it in here, what am I actually doing? So if I said x equals 1, then I could actually print out the value of x. What am I running it in right here, right now? The interpreter, exactly. It's going to do what I say. But I'm not saving it for use later on. Because if I want you to submit this as an assignment, you can't. So how do I create a new one, anybody? File new. Oh, that was easy. All right, now I'm going to call that, let's save it. We're going to call this one, we're going to save it on our desktop so we all can find it. No one says, I don't know where I saved it. I'm putting my desktop. I'm going to call it, what's the date? OG 30 in class. I'll get that? OG 30 in class.py. Okay. I know it's hard to see. AUG 30 in class.py. Now, I know you, well, can't do that. I wrote it in what's called camel case. Y'all ever heard of camel case? Let me see if I can't zoom in. So I can't zoom in. Darn. Oh, I got a way to do this. Snipping tool, my friend. Snipping tool. I'm going to go here. And now I'm going to save it in my pictures. Now I'm going to do 12 steps here. And I'm going to open it. I'm going to go to my pictures, and I'm going to open up this capture. Now I should be able to zoom in. Okay, y'all see that now? I know it's kind of grainy, but this is called camel case. Where the first letter of each word is a hump. So capital AUG, then a number. Capital I, small n. Capital C, small s. Okay? It's just what we normally do. Okay? All right, so I'm going to give it some comments in here. This is Ken's program to show a loop. Why is mine in all these different colors? Anyone know? I didn't use the pound sign, correct. The second thing is, since I didn't use a pound sign, it thought is a reserved word. And then it thought this apostrophe is actually means a character literal. So I'm going to put my pound sign in front. Ah, that's better. Okay. Normally when you make, okay, what's this thing called at the top of my program? It's called a prologue. Normally you're going to put in your name, you're going to put in the file name. Okay, and you're normally going to put in this program will demonstrate a while loop. Hopefully. I lost something there. Okay. So now I have a comment. So back to that code we saw. Let's go. Not that one. That's cheating. Do we want to use that one? Yeah, okay, we can do this. We can do this. So we're going to make this into Python. Well, no, we're not. Darn it. He does it different. Yeah, he wrote them both ways. Okay, now this is the first one. This is, we're going to do this one. Okay, well, that's a bizarre one. Okay, so we're going to write the code. So how would I say, in this case, we're just going to use x. Say x equals 1. Whew. Tired now. What is that? What's that statement saying? X is set to 1. Or I'm assigning the value of 1 to the variable x, because I'm using the assignment operator. Okay? Now I'm going to run this. I'm going to hit F5. Save it. Yes. Well, heck. What did it do? I just said it. And the cool thing is, since I just ran it, I can actually check inside the interpreter to see that it has a value. I can hit X. Yep, X has a value of 1. Which is kind of cool. Let's make sure we didn't cheat. Let's change it to Y. That way it's not that other code. I'm going to run it again. I want to check the value of X. X no longer has a value, but Y does. See that? So it does work. Okay? Let's go back to X. All right. So now we need to make our while loop. While turned kind of an orangish yellowish because it's a reserved word. While x is not equal to 0. Look good? Now, here's another question for you. Should I sit here and write this entire program and then hit compile or run or whatever? Should we do that? No. So many people do that. They write the entire program, then they go run. Well, it's hard to sometimes fix errors because, so I'm gonna run it now. Does it work? Anybody? Come on, someone should be following along. Shouldn't work. It's gonna be like, It's like, whoa, what the heck did I do wrong here? Okay, there's a problem. We had an invalid syntax. With Python, we actually have to put a colon here. So I'm going to F5 it again. So what's wrong now? My error says, oops, sorry, unexpected EOF while parsing. Don't have a, what now? Right, we're saying while is 1 equals 0, but it's like, okay, so while 1 is not equal to 0, it's like, okay, so while 1 is not equal to 0, I need the rest, so it's like saying, I've reached the end of the file. EOF is in the file. Hey, I've reached the end of the file, and you haven't told me what the heck you want me to do. It's kind of like, call my wife, hey, on your way home tonight, that's what we're saying here. While x is not equal to 0. Okay. Now, anyone ever heard of something called reverse Polish notation?
You told us about it last time.
Well, funny story. More about that today. I have a student. Not going to mention his name. Actually, hold on. All right. So let's continue on. So we have our loop here. So we're missing our statement. Well, what did we want this sucker to do? Okay, let's actually go down and look at his code, because I don't know which one he's trying to do it on. Okay, well, x not equals 0, get input. Enter a number. Okay, so now I'm going to do x equals, not that equal, equals, input. Please enter, 0 to quit. Okay. Ever got something similar to that? Doesn't have to be exact. Something similar. So please enter a number. Let me try to move this up a little bit. Okay. So now let's run this thing. Save. What the heck? What's the problem now? So how do I fix it, you think? I must indent it. In Python, with the while loop, whatever pertains to the while loop must be indented by one space, or one tab. So there you go. Now let's run it. Okay, enter a number. 5, 6, 0. What the heck? So I didn't tell what to do. Great, we're broke. Control C, and it stops it. Control C will do keyboard interrupt. Okay? Now, looking at my code here, does that look good? What's wrong with it? It drives me crazy. What? Yeah. How about this? Is that what you're saying? This part here is crazy. So I need to fix that. I would probably put a colon space. So that way, even though the program sucks, now it just looks better, you know? And actually, I would probably start with a capital letter too, but you know, that's okay. We don't want to be too perfect. All right, so we have that. Now, x equals xflow. Let's talk about what the heck that does. x equals float x. Wow. So I'm assuming x is fixing to go to my pool. What do you think? Think that's what it's doing? It's going to go float. Well, a float is a variable type. It's actually one of the largest there is. There's integer, and then there's double, and then there's float. Okay. How big can a float variable be? Well, let's find out. How big can a float be in Python? I keep putting a G at the end. I don't know why. Okay, what is the maximum float in Python? The maximum float is a very large number. 1.79 blah 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 e plus 308. Everybody know what e plus 308 means? Right. So that right there is the maximum float value. So that means scientific notation plus 308 means take this decimal space, move it to the right 308 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and a bunch of zeros. Okay, so really, I mean, is that a big number? Yeah, huge number. So if I'm gonna write code and I want to run it somewhere, would it be a good idea to make everything a float? No, because I mean, potentially you're wasting a lot of space in memory. Okay? All right. So let's continue on here. All right. Now, we're saying if x is not equal to 0, again, let's do that one. If x is not equal to 0, colon again, what do we want to do to it? Y equals x times 2. Y equals x times 2. Print y. We good? Let's see what it does. Okay. 5, 6, 7, 8, 9, 0. Okay, so it quit, but it did work correctly. Okay. Was it actually printing out what I wanted? Not really. Well, what was happening was this section here needs to be part of the while loop. Okay? Because when I ran this, let me run this one more time. 5, 6, 7, 8, 9, 0. am I seeing the results at all? Okay, I didn't do it. Now let's by moving this inside my while loop, whoops, let's try this. Oh, now we're actually getting some results. See how that works? So now what we got is setting x to 1 while x is not equal to 0, get input for a number, convert it to a float, and while it's not equal to 0, double it and print it out. So that's why it's doubling and printed it out. When I did a 0, you'll notice it didn't double and it didn't print it out. And it quit. Okay? Because when it got to the end here, it goes right back up to the while every time. And it kept checking. When while was equal to a 0, it quit. Make sense, everybody? Pretty simple. Yes, ma'am.
Mine is the top exclamation point next to the X. Mine says invalid syntax, and that part's highlighted.
That right there?
Yeah.
But you have the equals there with no spaces or anything? Let me see what you got here.
1 second. I had spaces between equals and
Oh, is it working now?
not the other one. Oh, just because that.
You shouldn't need that space there.
Okay. What is this?
Oh, okay. Well, try that. Try that. Yeah, you need to indent under the F. Indent it over. Indent that one. And indent that one. Now. Hey,
Oh, but it's been giving me that message too.
name X is not fine. Okay. It's recording. Well, where is, you got Y is 1, there should be X is 1.
Oh.
That's be a big issue. Because you're trying to check the value of X and it doesn't exist. Let me show you, did that work? Okay. Let me show you the error she just had. One thing she had was, she had a Y here instead of an X. So this line was fine. It's like, fine, I got a variable Y. Then we got to this one, it says while X is not equal to 0, and it's like, X? I don't know what you're talking about. Okay? So, I'm really now, so you had a space between these two? Okay, yeah. You can't have a space there. And it's weird. Some languages allow it, some languages don't. Okay? Alright, so we got that working. So, any questions on that one? Pretty simple so far?
So why did you assign X to float?
Okay, let's comment that out and check it out. Alright. What the heck? I lost my... Close this out. Start it again, because I can't see what it's doing. There it goes. Let's say... great. Just in case you enter a large number. Oh, and it actually doesn't take 0 now either. Working with floats is really tough. See, and when I take off that, this no longer works. I can't give you an exact reason why, but when it's like this, okay, it's weird. Okay, so by adding it, it's, how can I tell you? Up here, what is X defined as? We're putting a number in it, but is it really a number? Working with floats is just tough. Okay, we probably could have done a double. That's all I can tell you. And it's like we're gonna learn about nulls later and blanks later. Oh my God, they kill me. Because a 0 is not the same thing as nothing. Do you agree? Yet a 0 is nothing. 0 has no value. It's a 0, but really it's not nothing. So working with that when programming is so hard to do. It's just really hard to do. And by converter flow, it just solves that problem. Okay. It's something to do with, how can I do this? I don't know if this will even work. No guarantees this will work. Yeah, naturally it's not going to work. Sometimes when you do basic math, okay, let me try this. There's a way to get it to screw up, but I can't remember exactly how to do it. Yeah, that's not going to do it either. It gives us more precision is what it does. Because sometimes when you divide numbers, you ever seen Superman 4, Richard Pryor?
Yeah.
What did he do in there? Y'all remember what he did? He steal half a penny from every paycheck. It's kind of like when you divide numbers, sometimes they're not really the right number. There's a little bit left over. It might be 85 decimal places down, but it's just hard to work with. Okay? And what's pi? Something divided by something? What's the number? Is it 22 divided by 7? 21 divided by 7? What the heck is pi? Let's find out. 3.1. No, that's not it. It's got to be. Y'all know what pi is. Is it 21 divided by 7? Okay. Darn it. No, that ain't it either. Is it 23? I can't remember what it is. No? It's like pi. It's a number that never ends, but just leave it there. Okay, I'll try to get a better explanation for you, whoever asked that. I think it was you over there, but it makes it work better, put it that way. Okay, we're almost running out of time, so we can also loop through here using user response. Now we're not having to do this section, this whole X part, but we don't have time to finish it now. And so kind of get an idea what we're doing? How all this works and how to do it in Python. I know you're not experts at this point. We really haven't covered anything in Python. I haven't told you what any of this stuff really does. It's kind of like I told you what X++ is, but we really don't know what X++ is yet. So we will cover that more, but I want you to save this. It should function just like this. And if I hit 0, it should end. Okay? And put it in the one, I think it says conversion Python. Put it in the bottom one, the homework for today.
So just turn this in.
Yep, turn that in. Put it in the one called double 2. Okay? Sound good? All right. Y'all can see double 2, can't you?
No.
We have conversion too.
Oh, double 2's on the second page.
Yeah, in the bottom. Down at the bottom. In class.
I can't turn it.
It ended on the 28th.
Did it?
It's showing me.
Hold on. My bad. I'm gonna change. I ended on the wrong day. My fault. There you go. You can do it now. You might have to log off, log back on, or refresh, or clear your cache or something, but it should let you. Everybody see double 2 now?
Yep.
All right. Sorry about that. My bad. So Monday. What are we doing Monday? Oh no, we're cleaning my pool. I mean, you don't need to help, but I'm
Oh
doing
yeah,
it.
we don't have school.
We don't have school.
We're putting it in the double 2.
Oh yeah.
Put it in double 2. I probably should just rename them in class 8:30 or something, but that's just the names he had on there. So, all right. Any other questions on this before I'm gonna stop my recording?